Welcome to Pindar Poetry. We hope you learned something new.
You start by locking prerequisites and taking immediate action. Verify a GPU with 8+ GB of RAM or plan CPU fallback because performance depends on it. Install Python 3.10 and create a virtualenv, then add CUDA drivers if using NVIDIA. Once done, pick a model family, open source LLM speed prototyping, while custom nets give control. Make sure to clone the baseline repo and run its smoke test so you have a working pipeline before you build further. Now integrate the model and feed it quality data. You preprocess into JSONL, clean duplicates, and split 80/10/10. This reduces overfitting and speeds iteration. Choose a tuning strategy, low R-ray for efficiency, full fine-tuning when you need precision. It matters because training cost and latency differ considerably. Once training config is ready, implement quantization and batching to cut memory and boost throughput. And make sure to validate outputs on held-out examples to catch bias or hallucinations early. Finish by packaging and deploying the virtual AI into a reliable runtime. You containerize the model, tokenizer, and an API server. This ensures reproducible deployment across hosts. Once deployed, wire monitoring for latency, error rate, GPU utilization, and input drift so you can respond to regressions. Then add fallbacks, rate limiting, a smaller model, and output sanitization to keep users safe. If things break, restart the service and check logs for OOM or tokenizer mismatches. That single check solves most issues.
Thanks for watching. Consider subscribing if we helped you.